Hello guys, here's how you simplify expressions with rational exponents. Before we are going to simplify expressions, let us define what rational exponents are. Rational exponents are exponents expressed as fractions. Say for example, 9 raised to 1 half, 4 raised to 3 halves, 8 raised to 2/3, or 16 raised to negative 3/4, or 125 raised to negative 1/3. Notice that the exponents are in fractions or in the form of fractions, and these are called rational exponents. Rational is synonymous to the word fraction. Now, how can you simplify expressions with rational exponents? Let's have this example. Why is it that 9 raised to 1 half is equal to 3? So, in simplifying rational or expressions with rational exponents, it is very important that you know how to express the numbers into their prime factors. Let's say, for example, in this case, 9 raised to 1 half can be expressed as 3 times 3. But 3 times 3 is 3 squared. So therefore, 9 raised to 1 half is as good as 3 squared raised to 1 half. And using power of a power in your laws of exponents, power of a power, it means the powers are to be multiplied by the other power. So 2 times 1 half is 1. So you have 3 raised to 1 here, or simply 3. That's why 9 raised to 1 half is equal to 3. Another, what is 8 raised to 2/3? Why is it equal to 4? Well, again, we have to transform it into its prime factors. So 8 is 4 times 2, but 4 is 2 times 2. So how many 2's do we have? We have 3 2's multiplied by itself. Therefore, 8 is equivalent to 2 raised to 3. So therefore, 8 raised to 2/3 is 2 raised to 3 raised to 2/3. And when you multiply 3, which is the power of 2, and 2/3, you just have to multiply the numerators. 3 times 2 is 6 over 3. 6 over 3 is 2. So our result is 2 raised to 2, which is 4. Because 2 times 2, or 2 raised to 2, is 2 times 2, which is 4. Which is, of course, this one. And another. And now let us simplify more examples of rational exponents. 4 raised to 3 halves. Again, we have to express 4 into its prime factors, which is 2 times 2. So therefore, 2 raised to 2 is 4 raised to its original power, which is 3 over 2, or 3 halves. And multiplying the powers, because we apply power of a power, then we have 2 raised to 6 over 2, or simply 2 raised to 3, which is 2 times 2 times 2, which is 8. So 4 raised to 3 halves is simplified as 8. Another, 16 raised to negative 3/4. And 16, or before we can simplify it, or we will prime factorize it. Of course, we have to express the negative exponent first into a positive exponent. So we have to find the reciprocal of the expression with its corresponding positive exponent. So that's positive 3/4 now. And 16 raised to positive 3/4. Of course, we can now find the prime factors of 16. So you know that 16 is 2 times 8. You can use other factors of 16 like 4 times 4, and you will still come up with its final prime factorization, which is 2 raised to 4. 8 is 2 times 4, and 4 is 2 times 2. So how many 2's do we have? We have 4 2's. So therefore, 16 can be expressed as 2 raised to 4 and raised to its original rational exponent, which is 3/4. And we can actually cancel 4 over 4 in the denominator, and we can come up with a final or a simplified answer, which is 1 over 2 raised to 3. But 2 raised to 3 is 2 times 2 times 2, which is again 8. So 16 raised to negative 3/4 is 1/8. And how about this? 125 raised to 2/3. Again, 125 can be factored as 5 times 25. But 25 is not yet a prime factor, and of course it can still be broken down into smaller prime factors, which is 5 times 5. So we have this 3 5's. That's why 125 is 5 raised to 3 raised to another power, which is 2/3. And we can actually cancel also 3 over 3 here, which has now a simplified answer of 2. But 5 squared is 5 times 5, or 25. So 125 raised to 2/3 is equivalent to 25. How about 27 raised to negative 4/3? So again, break down 27 into its smaller factors or prime factors. That's 3 times 9, but 9 is 3 times 3. Oops, the exponent is negative, so we have to put it down in the denominator with the corresponding positive exponent. So we have 4/3 with the positive sign. And again, 27 is expressed exponentially as 3 cubed. So 1 over 3 cubed raised to 4/3. And since 3 can be cancelled by 3 in the denominator, then we can just have 1 over 3 raised to 4, or 1 over, what is 3 raised to 4? That's 3 times 3 times 3 times 3, or 81. So 27 raised to negative 4/3 is 81. 1 over 81. And now let's move on to this part of your module on what's new. So as you can see, this part has a table divided into 3 columns. The first column has an expression b raised to 1 over n, or an expression with a rational exponent. And on the second column, we are going to express b into its exponential form with an integral exponent, or an exponent which is a whole number. And on the third column, we have to go back to b raised to 1 over n from the first column and express it into a from here on the second column. Okay, so let's try the second row because the first row is done for you. 8 raised to 1/3. So 8 shall be expressed into an exponential form a raised to n. Now let us do the prime factorization to express 8 into exponential form. But 8 is 4 times 2. But 4 is not yet a prime factor, so we have to break it down into 2 times 2. Therefore, 8 is 2 times 2 times 2, or multiply 2 3 times by itself, or 2 raised to 3 equals 8. And on the third column, let's go back to 8 raised to 1/3. From here, 8 raised to 1/3 is 2. Another, negative 32 raised to 1/5. Again, let us express negative 32 into an expression which is in exponential form. So negative 32 raised to 1/5, or negative 2 times positive 16. But 16 can still be expressed as 4 times 4. And 4 is equivalent to negative 2 times negative 2. Also, 4, the other 4 is also negative 2 times negative 2. So we have how many negative 2's here? We have 5 negative 2's. So if we express negative 32 into its exponential form, that is equivalent to negative 2 raised to 5. Negative 2 raised to 5, which is equivalent to negative 32. So therefore, negative 32 raised to 1/5 raised to 1/5 is as good as, what is the value of a that we have solved here from the second column? Negative 2. Next, negative 1 on the fourth row, negative 1 raised to 1/4. But as you can see, our base is negative and our exponent is an even number. Since our b is a negative 1 and our exponent is an even number, there is no value for a raised to n equals b. So our answer is no answer. Also, our answer here is no answer. You will find it out later on our succeeding discussions. So in this part of your module, which is a table composed of 3 columns. The first column is an expression with rational exponents again. This, and on the second column, you have to express these expressions with rational exponents into power of power. Then afterwards, simplify it as an expression with an integral exponent. Okay, so let's do the second row and the third row. You know that negative 27 can be expressed into its prime factor as negative 3. So negative 3 and 9. And also, 9 can be expressed as negative 3 times negative 3. So using the prime factors, we have negative 3 raised to 3. Negative 27 is negative 3 raised to 3. Therefore, from here, negative 3 raised to 3 raised to 2/3. But multiplying the power with the other power outside the parentheses, you get negative 3 raised to 2. But negative 3 raised to 2 is equivalent to negative 3 times negative 3, which is 9. So the answer 9 shall be put on the third or under the third column. So 9. Okay, so let's move on to the third row. 32 raised to negative 3/5. Since it has a negative exponent, then we can simplify it by putting that expression in the denominator with a positive exponent. So this is positive 3/5. Positive 3/5. Now, let us express 32 into its exponential form. So 32 is 2 times 16, while 16 is 2 times 8. And 8 is 2 times 4, while 4 is 2 times 2. So how many 2's are there? There are 5 2's. So therefore, negative or 32 raised to negative 3/5 can be expressed as 1/2 raised to 5 raised to 3/5, or 5 is to be multiplied with another power, which is 3/5. So by method of cancellation, you can simply cancel 5/5. So therefore, 32 raised to negative 3/5 here is equivalent to 1/2 cube. But simplifying 2 cube, which is, we have already known that 2 cube is 2 times 2 times 2, or 8. So the answer here is 1/8. Now, on this part of your module, we are going to apply the laws of exponents in simplifying expressions involving rational exponents. So let's do number 1. X raised to 1/3 multiplied by x raised to 5/3. You know that if you multiply two bases with specified exponents, say x raised to m times x raised to n, what are you going to do with the exponents? Of course, you have to add them. x raised to m plus n. So that is what we are going to do with our rational exponents. We have to apply them, or we have to add them, sorry. So 1/3 plus 5/3. But when you add fractions with similar denominators, all you have to do is add the numerators. So in this case, 1 and 5. So 1 plus 5, 6. Then just copy the common denominator, which is 3. So in this case, that is x raised to 2. So the answer here is x squared. Next, number 2, a raised to 6, b raised to 9, c raised to 15, quantity raised to 1/3. In this case, we are going to apply power of a power. When we apply power of a power, we have to multiply the powers with the power outside the parentheses. So in this case, a raised to 6 raised to 1/3 is a raised to 6 times 1/3. And for b, b raised to 9 raised to 1/3. And for c, that is c raised to 15 raised to 1/3. So multiply it by 1/3. So therefore, let us simplify. A raised to 6 raised to 1/3 is a squared. B raised to 9 raised to 1/3, that is b raised to 3. And c raised to 15 times 1/3. 15 times 1/3 is 5. So this is the final answer. There is a typographical error here. There should be a c raised to 5 here. Okay? Next, number 3. Again, multiply a raised to 1/4 by a raised to 2/3. So since the exponents are in rational form again, they are 1/4 plus, we have to add the exponents because according to the law on product, you have to add the exponents. 1/4 plus 2/3. But 4 and 3, which are the denominators, are not similar. So we have to find the least common denominator. If the denominators are 4 and 3, then the least common denominator is 12. As you can see here on our given, so the denominators are 12. Now the problem is, what shall be the numerator? So you have to transform 1/4 into a new fraction such that the new denominator is 12. It's just as easy as multiplying 4 by 3 to get 12. So multiplying 1 also by 3. So it's 3. Also, 2 and 3 has, or these 3 shall be transformed into 12. So what did we multiply to 3 to make it 12? Yes, multiply it with 4. So that's what we are going to multiply to both the numerator and the denominator. We have to multiply them also by 4. So this is 8 now. And so we have similar denominators now. So we can just add the numerators. 11 over 12. So a raised to 11 over 12 is the final answer. And next on number 4, it's a division or it's a quotient. So when it is a quotient, you just have to divide or subtract the exponents. So when you subtract exponents, you have 8 raised to 5 third minus 4 third. And since they are similar fractions because they have the same denominators, you can immediately subtract the numerators. So that's 8 raised to 1/3. And as you can see, 8 can be expressed into an exponential form, which is 2 raised to 3. 2 raised to 3 raised to 1/3. Again, applying the power of a power, we have 3 times 1/3 is 1. So we can only have 2 raised to 1 or simply 2. So the final answer here is 2. And for number 5, since this is a quotient and at the same time there is a power outside the parentheses, we can say that that is a quotient of a, or power of a quotient, I should say. So you have to distribute the power again to every part of the fraction into the numerator and into the denominator. So this y raised to 2/3 times 2, y raised to 2/3 times, oops, should be, this should be 2. Let's fix this. This should be 2, and here is 2. Then multiplying 2 times 2, here is 4, and since the denominator is 3, then still it's 3. And below this bar, our denominator y raised to 1/2 times 2, so you have to multiply the numerator 2 with the numerator 1. So y raised to 2 over 2. And simplifying further, they are y raised to 4/3 divided by y raised to 2 over 2. So applying the law on quotient, you have to subtract the exponents. So you have 4/3 minus 2 over 2. And the denominators are 3 and 2. So you get the least common denominator so that you can subtract these two fractions. If the denominators are 3 and 2, then the least common denominator, or the smallest denominator that is common to 3 and 2, is 6. Now, transform 4/3 into a new fraction such that the new denominator is 6. It is as good as multiplying 3 by 2 so that it becomes 6. You should also multiply 4 by 2 and it will become 8. Same true with 2 here in the denominator. To make it 6, of course, what did you multiply to it? You multiply it with 3. So that's what you're going to do with the numerator 2 also. You multiply it with 3 and it becomes 6. And so the final answer is y raised to, you can now subtract the numerators of the rational exponents. 8 minus 6 is 2 over 6 But 2 over 6 is a fraction that can still be simplified into its lowest term because the numerator and the denominator can both be divided by a common factor, which is 2. So divide all by 2, and that is 1 over 3. And here is it. And here it is.